Alright, we're in Chapter 11 of the Helicopter Flying Handbook. Chapter 11, page 10 of 24, at the end of page 9. Settling with power, vortex ring state. Alright. Vortex ring state describes an aerodynamic condition in which a helicopter may be in a vertical descent with 20% up to maximum power supply and little or no climb performance. The term settling with power comes from the fact that the helicopter keeps settling even though full engine power is applied. And normal out-of-ground effect, OGE, hover, the helicopter is able to maintain stationary but by propelling a large mass of air down through the main rotors. Some of the air is recirculated near the tips of the blades, curling up from the bottom of the rotor system and rejoining the air entering the rotor from the top. This phenomenon is common to all airfoils and is known as tip vortices. Tip vortices generate drag and degrade airfoil efficiency. As long as the tip vortices are small, their only effect is a small loss in rotor efficiency. However, when the helicopter begins to descend vertically, it settles into its own downwash, which greatly enlarges the tip vortices. In this vortex ring state, most of the power developed by the engine is wasted in circulating the air in a donut pattern around the rotor. In addition, the helicopter may descend at a rate that exceeds the normal downwash-induced flow rate of the inner blade sections. As a result, the airflow of the inner blade sections is upward relative to the disc. This produces a secondary vortex ring in addition to the normal tip vortices. The second vortex ring is generated about the point of the blade where the airflow changes from up to down. The result is an unsteady turbulent flow over a large area of the disc. Rotor efficiency is lost even though power is still being supplied from the engine. A fully developed vortex ring state is characterized by an unstable condition in which the helicopter experiences uncommanded pitch and roll oscillations, has little or no collective authority, and achieves a descent rate that may approach 6,000 feet per minute if allowed to develop. A vortex ring state may be entered during any maneuver that places the main rotor in a condition of descending in a column of disturbed air and low forward airspeed. Airspeeds that are below transitional lift airspeeds are within this region of susceptibility to settling with power aerodynamics. This condition is sometimes seen during quick stop type maneuvers or during recovery from auto rotation. All right. The following combination of conditions is likely to cause settling in a vortex ring state in any helicopter. A vertical or nearly vertical descent of at least 300 feet per minute. Actual critical rate depends on the gross weight, RPM, density, altitude, and other pertinent factors. The rotor system must be using some of the available engine power, 20 to 100%. The horizontal velocity must be slower than effective transitional lift. Some of the situations that are conducive to settling with power conditions are any hover above ground effect attitude, especially attempting to hover OGE at altitudes above hovering ceiling of the helicopter, attempting to hover OGE without maintaining precise altitude control, pinnacle or rooftop helipads, when the wind is not aligned with the landing direction, in the downwind and steep power approaches in which airspeed is permitted to drop below 10 knots depending on the type of helicopter. When recovering from a settling with power condition, the pilot tends first to try to stop the descent by increasing collective pitch. However, this only results in increasing the stalled area of the rotor, thereby increasing the rate of descent. Since inboard portions of the blades are stalled, cyclic control may be limited. Recovery is accomplished by increasing airspeed and or partially lowering collective pitch. In many helicopters, lateral cyclic combined with lateral tail rotor thrust will produce the quickest exit from the hazard, assuming that there are no barriers in the direction. In a fully developed vortex ring state, the only recovery may be to enter auto rotation to break the vortex ring state. Okay, so recovery is accomplished by increasing airspeed and or partially lowering collective pitch. Tandem rotor helicopters should maneuver laterally to achieve clean air in both rotors at the same time. For settling with power demonstrations and training and recognition of vortex ring state conditions, all maneuvers should be performed at an altitude of 2,000 and 3,000 feet above ground level to allow sufficient altitude for entry and recovery. To enter the maneuver, come to an OGE hover, maintaining a little or no airspeed any direction, decrease collective to begin a vertical descent. And as the turbulence begins, increase collective, then allow the sink rate to increase to 300 feet per minute or more as the attitude is adjusted to obtain airspeed of less than 10 knots. When the aircraft begins to shudder, the application of additional up collective increases the vibration and sink rate. As the power is increased, the rate of sink of the aircraft in the column of air will increase. If altitude is sufficient, some time can be spent in the vortices to enable the pilot to develop a healthy knowledge of the maneuver. However, helicopter pilots would normally initiate recovery at the first indication of settling with power. Recovery should be initiated at the first sign of vortex ring state by applying forward cyclic to increase airspeed or simultaneously reducing collective. The recovery is complete when the aircraft passes through the effective transitional lift and normal climb is established. Common errors would be too much lateral speed for entry into settling with power, excessive decrease of collective pitch. We'll hold off there. That was page end of 9 and 10 of 24 in chapter 11. All right. See ya.